Assalamu alaikum to you all. So far in this data structures course, we have learned most of the basic data structures, including the following. Arrays. Arrays, actually you learned it right from programming 1. But in this course particularly, we learned about singly linked list, doubly linked list, stacks, and queues. We have also learned about recursion, which is a very important programming technique. As I emphasized when we were studying recursion, you will find it particularly useful when we come to the implementation of tree data structure. This is because trees are, of course, naturally recursive. So basically we are halfway through the course, and in this second half we shall study more advanced data structures, namely trees and graphs. Towards the end of the course, we shall also study how to apply data structures in the implementation of memory management. Right. So in this first lecture about trees, these are our objectives. First, we learned about the comparable interface. As I probably mentioned, apart from recursion, which is very much required for us to successfully implement the method of trees, we also need to understand this interface, as I will explain shortly. So if you like, it is one of the ingredients or prerequisites for you to be able to learn trees successfully. Now, once we understand about the comparable interface, then we can begin our study of trees. We shall start by looking at general trees, learn their definitions, their basic terminologies, and then we narrow down to binary trees, which are special types of trees. Again, we're going to learn the basic terminologies about binary trees. There are different types, but then again, that's not our target. We still need to narrow down further to binary search trees. It is binary search trees that we are actually going to implement. So we shall learn in detail the operations of binary search trees and also implement them as Java code. In particular, we will learn about searching, traversal, insertion, and deletion. Right. So let's start with the comparable interface. As a background to the comparable interface, let us recall the equals method, which we normally use to compare two objects to check if they are equal or not. As we all know, this method is defined in the object class. Object class, of course, is the super class of all Java classes. Therefore, any class that you write as a user, it automatically inherits this method. However, the object class, the way the equals method is defined in that class is such that it compares two objects based on their memory location, which is usually not very useful for us. For example, suppose you define two student objects, student S1 equal to new student 123 as the ID, Amr as the name, and 3.5 as the GPA. And you define another student S2 but with exactly the same data. Obviously, since you use new to create each of these, they will be allocated memory independently in the RAM. So S1 will be allocated its object in the RAM, and S2 will also be allocated its object in a different location in the RAM. And therefore, if you rely only on the implementation of the equals method in the object class, and you attempt to check whether S1 is equal to S2, I guess you will think the result will be true, since the two objects are having the same data, both of them the same ID, the same name, and the same GPA. Unfortunately, this is not the case, because as I said, the implementation in the object class compares the two objects S1 and S2 based on their memory location. And since they are in different memory location, this if statement will return false. It is for this reason that actually when you write your own Java class, you are always expected to override the equals method, so that you decide when two objects are equal based on your own criteria. We have in fact done this, as you recall, with the student class in our labs. In the student class, we made two student objects to be equal as long as they have the same ID number. Now, this is just a background. In many data structures, particularly with trees that we are going to study now, the equals method is not enough for us, because in addition to being able to check whether two objects are equal, we also need to check whether one object is less than another or is greater than another. Right. So the question is, are there methods, let's say less than or greater than, that are inherited from the object class that we can override, just like the equals method, to allow us to compare two objects for less than or greater than? The answer to this is no. There are no such methods. Instead, Java provides you with the comparable interface. The comparable interface is in the java.util package, and actually it has only one method, as you can see here. The method is called Compareto. Now, if you write a class for which you will want to compare objects of that class for less than and greater than, then you are expected to implement this interface in that your class. Right. Now, the method Compareto, if you notice, is not exactly like the equals method, because it is not Boolean, it is int. So the question is, how does it work? Basically, it compares the current object against the one that is passed to it as argument, and it's gonna return one of three possible values: a negative value if the current object is smaller, 0 if the two objects are equal, or a positive value if the current object is bigger. Notice here the value doesn't have to be -1. Any negative value is fine. And similarly for positive value, it doesn't have to be +1. It can be any positive number. If the method returns a positive number, it means the current object is larger than the one passed to it as parameter. Right. Now there are some notes that we should know about the comparable interface. I will call them good news. One is that all the wrapper classes that we know and many other Java classes, I will show you in a moment the classes that actually implements the comparable interface. All of them implement the comparable interface. So if you are dealing with data that is of these types, you don't have to worry about checking whether your class can allow comparison for less than or greater than, because all these classes they implement the comparable interface. Just to show you the classes that implement the comparable interface in the Java library, let us go to the browser and suspend this slide temporarily and try to search for the comparable interface and see what you will get. So suppose you say, for example, Java comparable. As usual, it's better to go for the one from Oracle. So this is the interface comparable, and see what it is saying here: all non-implementing classes. In other words, all of these classes in the Java library, they implement the comparable interface. You can see among them, for example, the character class is there, the date class, the double class, the integer class, and so on and so forth. All these classes are inheriting this interface, and therefore if you have two objects of any of these classes, you can equally check if one object is less than another or if one object is greater than another. This is of course in addition to checking for equality. Right. So this is good news number one. The second good news is that Java provides for you a sorting method, or two sorting methods actually, that you can use to sort objects for free, provided the objects are implementing the comparable interface. This is the only condition. Now, depending on where you store your objects, in what type of collection, if you store your objects in a normal array and you want to sort those objects, then you should use the sort method that is inside the arrays class. So just say arrays.sort. I will show you this later, how actually this sorting works. On the other hand, if your objects are stored in a Java collection like array list, linked list, vector, and so on, then you should use the sort method in the collections class. So you should say collections.sort, pass your data structure that contains the comparable objects, and the object will be sorted automatically. Again, we shall see an example of this. So this is briefly about the comparable interface. Now let us learn how to implement this interface. This is the small class called employee, that is designed to implement the comparable interface. Probably I will explain this class better from NetBeans. So let's switch to NetBeans to see about this class. This is the employee class. So the class heading of course is going to implement the comparable interface. So you have to say class employee implements comparable. Now, two things to note here. First, of course, you have to import the java.util package, because that is where the interface resides. The second point to note is, if you recall, the interface has a generic type T. Okay. Now, at what point do you specify the type for this T? It is actually at the point of creating your class. Okay, you have to say comparable of type the same class that you are defining. You will use it as the T. Why? Because remember, the compare to is supposed to compare two objects. The current object, of course, the current object is an employee object, and another object. So that other object must also be an employee, because otherwise you cannot do the comparison. You can only compare apple and apple, or orange and orange, not an orange and an apple. Yeah, so when you declare your class and you say implement comparable, you should give the same name as your class as the value for the generic type T. Okay. Now our employee class has two instance variables: employee ID of type int, actually three instance variables: employee ID, employee name, and employee salary, or we just call it salary here. Now you may notice there's another variable I, but this variable is not an instance variable. As you can see, it is a static variable. You may want to know what is the difference between an instance variable and a static variable. Basically, an instance variable is a variable for objects that will be created from this class. For example, if you create 10 different objects, each of the objects will have memory location for the instance variable, so that the ID of object 1 is going to be different from the ID of object 2, different from the ID of object 3, and so on. But if you define a variable as static, it means there is only one copy of this variable, and it's going to be for the class itself, not for the objects. So this type of variables are actually called class variables. Now I'm using it here for a purpose. I wouldn't want the user to provide the ID of an employee object he is creating, because ID is a unique field, and therefore it should be different for each object. If you allow the user to provide the value for it, he may give the same ID for two different employees. So what I will do, as you will see in the constructor in a moment, I will be assigning the IDs 1, 2, 3, and so on. One will be for the first object created from this class. Then next one will have ID equal to 2. Next will have ID equal to 3, and so on. Yeah, so this variable is not an instance variable. It's just for the class, and this is the purpose of it. Okay, that's about the variables. Now what about the constructors? Let's look at the main constructor here. The main constructor, as you can see, it receives the employee name and employee salary, and it will use these values to initialize the two instance variables. However, as I said, we don't allow the user to provide the ID. Instead, we initialize the employee ID with the variable I. So as you remember, we initialize I to 1, therefore the first value assigned to employee ID will be 1. But immediately after that, I will be incremented by 1, so that the next object created will have ID 2, and so on, like that. Yeah. The default constructor here is similar, except that it doesn't receive any argument. So we just initialize the two instance variables with some dummy values. But the employee ID must have a value. So we are following the same technique. We're going to initialize it to I and then increment the I. Okay. So those are the constructors. Now in terms of the methods, here of course we have the toString method, which will print the information about the employee. So basically printing the ID, name and salary separated by the tab character. But here is the most important method. We claim that we are implementing the comparable interface. Therefore, we must implement the method of the interface. So we must have the Compareto method. As you can see, the Compareto method will receive another employee object, and it's going to compare it with the current one, referenced by this. Okay, the current one, of course, is the one that has these values. So now the question is, how do you compare employees? Among the three variables that we have, which one do you think is more appropriate to compare two employees and say one is less than another or one is greater than the other? The one that looks more sensible actually is salary, because naturally we will think the employee that has the larger salary is probably more important than the one that has less salary. Yeah, so that is the one we're going to use to implement our Compareto. Name obviously doesn't matter, and similarly the employee ID are just numbers 1, 2, 3. We don't know, maybe the manager just came now, so he has a big value for the ID, or he was there much earlier, so he has a small value for the ID. So ID is probably not appropriate to measure which employee is less than or greater than another. So if we decide we are going to use salary as our criteria for comparing less than or greater than, then this is how to implement the Compareto method. We check if this dot salary, meaning the salary of the current object, is less than other dot salary. So it's less than the salary of the other employee that we received as argument. It means the current object is less than the other object. So we're going to return a -1. Obviously, as I explained, you can return any negative value here. It doesn't have to be -1. On the other hand, if this dot salary is equal to other dot salary, it means the two objects are actually the same. They are equal. So we return 0. Else, which means this dot salary is greater than other dot salary, so in that case we're going to return 1. Yeah, so this is basically how to implement the Compareto. Finally, we have the equals method. Now here it is very important actually to make sure that the equals method does not contradict the Compareto method, especially if the two objects are equal. And the equal method should not say two objects are equal, and Compareto should say they are not. Therefore, if you are implementing Compareto, it's generally advised that you use it when implementing the equals method, so that the result they return will not contradict each other. Of course, we know the equals method, this is the signature inherited from the object class, and we cannot change it. So the argument we receive here is of type object. Okay, although the current object is of type employee. So how do we compare the two? The first thing we must do is to typecast the object that we receive as argument to make it to be of type employee. So here we define employee other becomes this object that we receive typecast to be of type employee. So that gives us two employee objects which we can now compare. So at this point we need to call the Compareto method and check if this dot Compareto other is equal to 0. Only then you should return true. So this makes sure the equals method will only return true if Compareto will also return 0. Okay, so this is our simple class employee that shows how to implement the comparable interface. Next is how do we use this class? And here I have a simple main class called test comparable. So in this I define an array list of employee. Call it list equal to new array list of employee, and I add 4 employee objects into this array list. List.add new employee Tamimi with salary 40,000, then Hussein with 20,000, Muhammad with 50, and Khalid with 70,000. Here I want to show you the sorting method that I mentioned earlier. I want to use the sorting method to sort these employees. And since array list is actually a type of collection, we should use the collections.sort method, okay, to sort our array list. But before that, I want to print the content of the array list before the sorting. So here I said before sorting, print each employee object in the array list. So for each employee E in list, print the E. Obviously this will print the content of the list in the same order that we added them. So Tamimi will come first, then Hussein, then Muhammad, then Khalid. So now after that we call the sort method, and again we use the for each method to print the list. Same code. The only difference now is before this printing we have sorted the array list. Let us run this code and see the output. Okay, so this is your output. Before sorting, as expected, we have Tamimi, Hussein, Muhammad, and Khalid. But after sorting, we have Hussein first. Why? Because Hussein is the smallest according to our definition of less than, which we did in the Compareto, because he has the smallest salary, so he is the smaller object or the smaller employee. Followed by Tamimi with 40, Muhammad with 50, and Khalid with 70. Yeah, so this is we are able to achieve simply by calling the sort method. All that is required for you to use the sort method is that your class from which you created these objects must implement the comparable interface. Let us now go back and show you what if your collection is not array list, it is a normal array. How can you sort those objects? So I have commented this part earlier. Let us remove the comments. By the way, this project that is demonstrating the comparable interface, it is there on the blackboard on our course page, and you can find it here as a zip file, comparable demo example. So you can download it and play with it and see how it works. Now, well, let's remove the comment. Here I create an array of integer. Okay, and suppose I want to sort this array. As we mentioned, integers, the wrapper class integer implement the comparable, and therefore integer values can be sorted. All you have to do is to say arrays.sort a, and you will have the elements sorted. Of course, as we learned in the lab, there is an easier way to print the array. Instead of using a loop, we can easily use arrays.sort, rather the toString, to convert our array to a string. So maybe let's do that here. Just say out okay. So now I want to convert my array to a string. To do that, you will say arrays dot toString, and then you pass your array as argument. So this will convert the array into a string, which you can now print. I want to do this before sorting and after sorting. So let us put one more of this statement here and one after calling the sort method. We can comment this for loop. No need to use for loop actually to print an array. You can just get it by calling the arrays.toString method. Okay, so let us run our code again, and we see the output. This is the output. This is the original array, and this is the sorted array. As you can see, -5 first, then 3, then 5, then 7, and so on. So again, this is achieved because the integer class implement the comparable interface. Okay. However, the main purpose of teaching you the comparable interface is really not for sorting. Sorting is just by the way. What we really want you to know is how do you compare, to check whether one object is less than another or is greater than another. So this next few lines will show us how. Suppose we have two employee objects, E1 equal to new employee armed with 20,000 salary, and E2 equal to Ahmad, new employee Ahmad with 30,000. How do you compare to check if E1 is less than E2 or if E1 is greater than E2? this is how it's very similar to the way you call the equals method, but also slightly different. You will say if E1 dot compare to E2, but you don't stop there, because as we know, compare to is going to return to you an integer value. So now you have to compare that integer value. How does it compare with 0? If the integer value you get is greater than 0, then by the definition of compare to, it means E1 is greater. So you can now say E1 is greater. Otherwise, you say E2 is greater or equal, of course, because not being greater means it can be 0 as well. Yeah. So this is very important, and we shall see how we use this a lot when we come to trees, because as we shall see, the type of data that we store in trees must be comparable, and if they must be comparable, then we can compare them to check which one is less than or greater than. So let us run this last part. Obviously you will expect this to be false, because E1, his salary is just 20. So if you compare with E2, you are expected to get a negative number, and again a negative number cannot be greater than 0. So the condition here is false. So it will not say E1 is greater, it's going to say E2 is greater or equal to. Let us run the code and see once more. Yeah, so you see here it's saying 6 Ahmad with this value is greater or equal. Now you may be surprised, how do we get 6, or why do we get 6? Obviously our I that we are using to increment the values has now reached 6. This is why the number 5, you see, number 4 was Khalid. The one that was not greater, which is Amr, I think, is the one that has ID 5. Yeah, because we created Amr before Ahmad, so the ID of Amr is going to be 5 and the ID of Ahmad is going to be 6. If you want to check, you can just print it out. Let's say S out E1. You will see that the ID is 5. Yeah, you see Amr has ID 5. Okay, so I hope this explained to you about the comparable interface, what is its importance, how to implement it, and also how to use it. We're going to need it a lot when we start talking about trees. Okay, I think I will pause here and save this part of the lecture as part 1 before we continue with the rest of the slides.